So today we're talking about area of the triangle, radians, arcs, and sectors. May seem like a lot, but it really kind of all ties in together. Like radians, arcs, and sectors kind of go together, and area of triangles like one little extra thing. So you guys are gonna be able to find an area of triangles, not just old school 1/2 base times height, but to find the area of any triangle, as well as be able to find arc lengths and areas of sectors and things like that. So we're gonna start off with the area of the triangle. It's a very simple formula. It's 1/2 BC sine A. I do believe that is how it's written in your reference booklet. But do realize that B and C, those and A, those are all interchangeable. Basically, area of the triangle is used when you have, when you know two sides and an included angle. That is when you use this area formula. So B and C represent the sides, and then A technically just represents the included angle. Okay? So don't let, the lettering throw you off. You're basically using the situations for side and side. Okay? Alright, so we're going to find the area of this triangle here, ABC. As you can see, this is the situation side angle side. So if we wanted to find VA, we could use law of cosines. But it's not asking us to do that, so it's asking to find the area of a triangle. Using this formula is very simple. It's just 1/2 times 8.4 times 7.8 times the cosine of 82.7. Okay? Now, if you wanted to use old school 1/2 base times height, you would need to create your own height, figure out what this base is. It'd be a lot to find, just something as simple as just doing 1/2 the two sides cosine of the angle. Okay? So we type that in and we find our area to be, say again? And because we are talking about area, you want to make sure you include your units, which are square, because we are talking about area. Okay? It really is straightforward. A lot of times you just have to find, you might have to find that included angle, and then it asks you to find the area. Usually it goes together with you using law of sines or cosines, and then finding the area. Okay? All right. Let's take a look at this one. So this one, it says the area of the triangle is 50 centimeters squared, and we're looking for theta. Okay? So you can even use the area formula to find angles or side lengths as well. Okay, the formula is 1/2, or A equals 1/2 BC sine A. Again, the letters are interchangeable. Okay? We know the area to be 50 centimeters squared, so we can plug that in for A. And we know our two sides that are going to get multiplied together. That's 8.2 and 13.7. We can plug those in. The one thing that we don't know is our angle. So pretty much this is nothing but an equation that we solve for theta. Okay? How do we solve for theta? What do we do? Multiply all these together and then divide. Okay, so what's half 8.2 times 13.7? 56.17. So we basically have 56.17 sine of theta. We'll divide both sides by 56.17. And then, of course, you cannot forget, it doesn't matter. Whenever we're looking for an angle, we're always going to what? Take the inverse. So when we do that, we'll actually get our angle to be 9. And you could always double check by basically plugging that into the formula for area. 1/2 8.2 times 13.7 times the sine of 62.9, it should give you 50 degrees. If you plug in the rounded answer, of course you're going to probably be like 50.00000012, whatever. But it's 50. Question on area of the triangle. Alright, moving forward, talking about radian measures. Angles can also be measured in radians, okay? A radian is basically directly related to measurements within a circle. Radians are more associated within a circle. Okay? And a radian is defined as the size of the central angle subtended by an arc, which is the same length as the radius of a circle. So this picture kind of gives you that visual. Okay, you basically have a central angle, basically the vertex is in the center. And when it hits your circle, that arc is basically the same length as the radius. That length is the same length as the radius. And the measure of that central angle is the measure of the arc. Alright. So arc length. Arc length is one of the things where radian is actually used over degree. Arc length is basically the distance from one point to another point on the circle. It's represented by S. Okay, the formula of S equals R times theta. R is your radius, and theta is your central angle, which is always measured in radians. Please make sure that when you're finding the length of an arc, or the distance from one point to another point on a circle, you are using radians. So this is where you actually switch your calculator between being in degree mode and also being in radian mode. Okay? And they can really even try to throw you off. They might give you a circle and the angle is in degree. They'll actually define the arc length. You have to convert that degree to radian, which we'll talk about in just a second. So just remember, that's always measured in radians. To find the area of a sector, it's basically the area of this like piece of pie right here, slice of pizza. It's 1/2 times your radius squared times theta. Theta in this formula is also in radians. So anything that involves a circle, a sector, an arc length, your theta needs to be in radians. Okay? Everybody understand that?
Often those for ourselves.
Huh?
On the test, like it won't say, hey, switch to degree and radian.
No, it won't tell you when to be in which mode. You'll just have to know the switch. Now, one thing actually I can say is that with these particular formulas, you won't have to worry about sine or cosine necessarily. And so once you convert any degrees to radians, then you're fine to stay in degree mode. But once you actually involve a cosine or a sine, then you actually have to be in that mode. So say you're trying to find a triangle that's inside of a circle. When you actually use like log cosine's formula, they give you the degree in radians. Make sure you're radian mode. They give you the degree in angle. Make sure you're in degree mode. Or they give the angle in degrees, then make sure you're in degree mode. So, look at an example here. We're going to find the length of the arc, and we're also going to find the area of the sector. Start you off real basic, and then we'll get to a few more challenging problems. Alright, so we're finding the length of the arc, which subtends the central angle of 2.5 radians in a 2.5 radians in a circle with a radius of 7 centimeters. Okay, so that subtends just basically means it intersects the circle to form this arc. We are looking for that length. So it's very simple. Use the formula for arc length, which is S equals R times theta, making sure that theta is in what? It's in radians. The angle is in radians, which it is, so we don't have to worry about any switching over. So literally all we're going to do is just do 7 times 2.5, which is 17.5. And it's going to be, that's the length from one point to the other point. That's how long that arc is. Okay? It's pretty straightforward, pretty simple. Just make sure that your theta is in radians. For B, we're looking for the area of a sector, which is the formula 1/2 radius squared times theta. So it's pretty straightforward. Just plug in. We'll have r squared. R is 7 squared times theta, which is 2.5. We'll type that in. And basically this piece of pie is how big? It's that area. 61.5? 2.5? Is that exact?
Yes.
can write 61.25 centimeters squared, because that is exact. It wasn't rounded or anything like that. But you could also put it in three significant figures, and that would also be acceptable. Questions on that? This is a straightforward one. Okay? Alright. Let's look at this one. It says a circle has a radius of 2.5 millimeters. And identify the size of the central angle subtended by an arc of length 9 millimeters. So there's no picture here, but you kind of can already set this up, right? What formula are we going to need for this? S equals r theta, because you know the length of the arc is 9 millimeters, which means the 9 is going to go in for what? S, and you know your radius is 2.5, so that's going to go in for r. We're looking for theta, so easy enough. How do we find theta? Just divide. So what is theta? 3.6. Now realize that that is in radians. Okay, so that's 3.6 radians. So if you wanted to look at a visual picture of this, you have a radius of 2.5. You have the arc, which is 9 millimeters, and then there you go, your angle is 3.6. That's what it would look like. There was a picture associated. Questions? So 10 means basically that you have an angle where the center is at the vertex, and when it goes out to the sides, it hits the arc. It hits the circle creating that arc. That's in between the two. Look at this one. So, higher level one. Okay, so in a circle, you know the arc of AB is 7.86 centimeters. The area of the sector AOB is 23.58 centimeters squared. You have to find the central angle and the radius. So you don't know any of those things. You just know the actual place and the area. So did you set an equation? Anybody try to set up an equation? Kind of. What equation did you set up? Okay. Anybody set up a different equation? Okay, you have those two types of formulas. So you basically have two equations where you have two different variables that you don't know. You can do substitution or elimination. Okay? But which one are you actually going to use here? Which one? Substitution or elimination? It's going to be substitution. Elimination can only be used when you're having like addition or subtraction of your variables. In this case, you're going to have to do substitution. So basically, you're going to have to pick one of these formulas to solve for one of your variables and plug it into the other one and solve for one of your variables. Which equation do you want to solve for one of your variables? You want to solve the area one or the length one? Length probably is a little easier. Okay. What variable you want to solve for? Solve for theta. So to solve for theta, that means we're going to do what? Divide by the radius. So theta equals 7.86 divided by r. So that means we're going to plug that in for theta. So r squared times the 7.86 over r. Is everybody with me so far? This is more like an IB type of problem when you have to solve for variables. Now, how can I simplify this right-hand side? Well, I was thinking about like trying to maybe cancel some things, make it really nicer. You can cancel one of the r's at the bottom with one of the r's at the top, which you're technically multiplying. And can't you divide 7.86 by 2? What is that? 15 point what? 72.
Divided by 2?
Divided by 2?
3.93.
3.93? Okay. So this is basically what we have here. If we simplify before we get going, it kind of makes it a little bit easier. So 3.93 R. So all we have to do to find R is divide. So our radius is 6 centimeters. Okay? So the radius for these particular situations is 6 centimeters. How do we find theta? Plug it back in to that equation that we have for theta, and 7.86 divided by 6 is 1.31, and that is, of course, in radians. That's more like an IB type of problem, okay? You set up your equations. Do not forget systems of equations, substitution, elimination. Any questions? Okay. Now, like I was telling you guys before, sometimes they'll try to trip you up because they know that students will forget that arc length and area of a sector, the theta needs to be in radians, so they'll give you the degree measure, and then you'll like do the problem with the degree, and then get it wrong. Just forget to convert. So how do you go from degrees to radians? Well, you take the degree and you multiply it by pi over 180.
Slowly getting closer to
Answer.
Slowly
Exactly.
getting
When will you ever have to convert radians to degrees? Well, let's say you're doing a problem that involves loss signs and cosines. Your calculator is already in degree mode, but they give you the measure of the angle in radian. Well, you can always convert that to degree by multiplying the radian by pi over 180. Okay? And I mean, it's like literally, it is straightforward. Okay? So say your angle is 90 degrees and you want to convert it to radian. You just multiply by pi over 180. Multiplying straight across, that's 90 pi over 180, and you reduce to be what? Pi over 2. Simple as that. Let's say you have pi, and you want to convert that to degrees. You just multiply that by 180 over pi. 180 pi over pi, the pi's cancel out, and you're just left with 180 degrees. Okay? If you want to simplify before you multiply straight across, I suggest that. You know, you can say, hey, 90 goes in 180 2 times, oh, that's just pi over 2. My pi's cancel out, that just leaves me with 180. So all I want you guys to do is I want you guys to practice just with conversions. I want you to convert the following to radian, and then the bottom convert the following to degrees. And I'll check back in on you in just a second. All right, so even though, yes, you can use your calculator for this, you should also be able to do this without a calculator. So just real quick, if you're converting this to radians, you will multiply it by, again, pi over 180. If you notice, 30 does go into 80 evenly, okay? First off, both of them into 0, so you can cancel that out. And then 3 goes into 18 how many times? 6. So this is basically pi over 6 radians, or as a decimal, the 3 significant figures will be what? What is it? Did you guys do it this way?
No.
No.
No, like you put the pi.
0.523.
Yeah, you put the 0.5.
Either one would be acceptable. The one at the top, though, that pi over 6 is going to be helpful when it comes to unit circle, which we are slowly eking towards, okay? So, do the same thing. 43 times pi over 180. Does 43 go into 180 at all? No. So then you just multiply straight across and you have 43 pi over 180. Or, what's the radian measure? In decimal. Radian. Okay? And then 60, you multiply that by pi over 180. And that is just pi over 3. 6 goes into 183 times, so that is just pi over 3 radian, or 1.05 radian. I know I see everyone's like typing, maybe just double checking, but okay. For this one, the convert to degrees is 2 pi over 5 times 180 over pi. Clearly, you see your pi's are going to what? Cancel out. And then how many times does 5 go into 180? The answer is 72. So how many times does 5 go into 180? So this turns into a 36. So 2 times 36 is 72 degrees.
180, 36 times. Not 72.
I thought you said 5 out of 360. Calm down.
Right? Pi over 9 times 180 over pi. Clearly your pi's cancel out. And how many times does 9 go into 180? 20. So your answer is just 20 degrees. Yes, you can, of course, multiply straight across in your calculator 180 pi divided by 9 pi, and you'll get the answer. Now this one, I can't do it using my method that I did for D and F because, hey, it's already in decimal form, the radian. So I basically multiply this by 180, I divide it by pi, and then I get what answer? Because I can't do any canceling out here. 2.3 times 180. 131.8 because it stops after 8. So technically this is 132 degrees. But again, this is just used if you ever have to convert radian degrees